Next topic is complex number. Main objective is to solve the quadratic equation whose discriminant is less than 0. That means it is not possible to find the solution in the system of the real numbers. In this case, we have to extend the real number system to a larger system so that the solution of the equation can exist. For example, if we take the quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0 for the quadratic equation, then its discriminant d will be equal to b square minus 4ac. And if it is less than 0, then the solution will not lie in the real number set, and we have to extend the real number set to exist the solution. Now we consider a simpler quadratic equation like x square plus 1 equal to 0. On solving, we will have x square equal to minus 1. Now there is no number exist in the real number set whose square is negative. So we introduce a new term that is called iota, and this iota is equal to root minus 1. This is an imaginary number. So on squaring, we will have I square equal to root minus 1 square, or we can say I square equal to minus 1. So for x square equal to minus 1, we can replace minus 1 by I square. This means x will be equal to plus minus I. So solutions of the x square plus 1 equal to 0 are x equal to plus I and x equal to minus I. So we have introduced a new term that is I, which is also called iota and is an imaginary number having the value minus 1. So on squaring or multiplying this with I, we will have I into I, and it is equal to root minus 1 into root minus 1. This will give the value minus 1. Further multiplying the I square with I, we will have I cube, and this will give I square have the value minus 1 into I, therefore I cube will be equal to minus I. Similarly, I4 will be equal to I square into I square. I square is minus 1 into minus 1, so it will be 1. So we can write that I is equal to root minus 1, I square equal to minus 1, I cube equal to minus I, and I raised to the power 4 equal to 1. In general, we can write that I raised to the power 4m plus 1 is equal to I, and it is having the value root minus 1, where m is a integer. Similarly, we can write that I raised to the power 4m plus 2, that is equal to I square, and it has the value minus 1. I raised to the power 4m plus 3, this will have the value of I cube, and it has the value minus 1. And I raised to the power 4m plus 4, that will be equal to I raised to the power 4, and it has the value 1. So using these results, we can write that root of minus a will be equal to root of minus 1 into root of a, and this root of minus 1 is iota, that is the imaginary number, so it will be equal to I into root a. Similarly, root of minus a into root of minus b, it will be equal to root of minus 1 into root of a into root of minus 1 into root of b. And root of minus 1 is iota. So we can write this is I into root a into I into root b. That is equal to I square into root a into root b. And we can write it is minus root a into root b. Similarly, we can find the value of 1 plus I whole square. This will be equal to, using the identity that a plus b whole square equal to a square plus b square plus 2ab. We have 1 square plus I square plus 2 into 1 into I. It will be equal to 1 plus I square have the value minus 1 plus 2i, and this 1 and minus 1 get cancelled, so 1 plus I whole square will be equal to 2i. Similarly, we can find the value of 1 minus I whole square. Here we will use the identity that a minus b whole square equal to a square plus b square minus 2 into ab. So using this formula, we will have 1 square plus I square minus 2 into 1 into I. So it will be equal to 1 plus I square is again minus 1 minus 2I, and 1 and minus 1 get cancelled and value will be minus 2I. Next we will take the algebraic operations on the complex numbers. For this we take two complex number, that is z1 equal to x1 plus iy1 and another is x2 plus iy2. So first operation is the summation of two complex number, that is z1 plus z2 will be equal to, first is x1 plus iy1 and another is x2 plus iy2. While adding, real number will be added with real number, so it will be x1 plus x2, and imaginary number will be added with imaginary, so it is iy1 plus iy2. So we can write further it as x1 plus x2 plus iy1 plus y2. Then difference of the two complex numbers, that is z1 minus z2. Again we can write x1 plus iy1 minus x2 plus iy2. It will be equal to, now again we have to subtract real number from real number and imaginary from imaginary. So we will have x1 minus x2 plus iy1 minus iy2. So it will be equal to x1 minus x2 plus iy1 minus y2. Third is multiplication. If we multiply two complex numbers, so it will be equal to x1 plus iy1 into x2 plus iy2. They are the two terms in each. So we have total four terms on multiplication, and which are x1 into x2 plus x1 into iy2 plus iy1 into x2 plus iy1 into iy2. We separate the real and imaginary parts. So real parts is x1 plus x2 and another is iy1 iy2. So we can write it is x1 x2 plus I into I, that is I square into y1 into y2, plus, and there is I common in other two terms, so it will be x1 y2 plus x2 y1. This I square we have given the value minus 1 because I is equal to root minus 1. So it is equal to x1 x2 minus y1 y2 plus I x1 y2 plus x2 y1. This is the product of two complex numbers. Next is division. Division of two complex number is z1 by z2, where z2 is not equal to 0. Otherwise, if z2 is 0, then division will become non-defined. It is equal to x1 plus iy1, this is the numerator, divided by x2 plus iy2, it is z2 which is denominator. To simplify, we multiply numerator and denominator by the conjugate of the denominator. Conjugate we will define later, but for understanding we can say that to find the conjugate of a complex number, we have to replace I with minus I. So we get conjugate. So conjugate of the denominator will become x2 minus iy2 if we replace I with minus I. So we multiply numerator and denominator by x2 minus iy2 divided by x2 minus iy2. And further simplify it, so numerator will become x1 x2 minus x1 into iy2 plus iy1 into x2 and then minus iy1 into iy2 divided by, and denominator will become, here it is of the form a plus b into a minus b. So we can write it is a square minus b square. So we will have x2 square minus iy2 square. Now we simplify these terms. We will have x1 x2, then we take the term which have I square, so it is minus I square y1 y2, because I square is minus 1, so we will give real number. Then remaining numbers are minus I x1 y2 plus I y1 x2 divided by x2 square minus I square y2 square. We know that I square equal to minus 1, so replace this value. It will be equal to x1 x2. I square is minus 1, so it becomes plus y1 y2 This is the real part minus plus, if we take I common, plus I common, then it will be y1 x2 minus x1 y2 divided by, and in denominator it will be x2 square and it become plus y2 square. So this is the division of the complex numbers. Next we have to state the condition for the two complex number to be equal. Suppose complex number z1 and z2 are equal. That means x1 plus iy1 is equal to x2 plus iy2, and they are equal only if x1 equal to x2 and y1 equal to y2. That means we can say real part of z1 is equal to real part of z2 and imaginary part of z1 equal to imaginary part of z2, then only two complex number z1 and z2 are equal. Next is modulus of a complex number and the conjugate of a complex number. These two terms are very important. Here we are just giving introduction of these two terms and detail will be discussed later. Suppose complex number is given by x plus iy, then its modulus is given by mod z, that is z within two vertical bar, and its value is root x square plus y square. We can also write it as x is the real part of the z, so it is the real square of z plus imaginary square of z. Similarly, the conjugate of the complex number is represented by z bar. We put a bar over the z. This represents the conjugate and its value is equal to x plus iy bar. And here we change I with minus I. So we will have it is x minus iy. Or we can write it is the real part of z minus I into imaginary part of the z.